I got this though. Welcome to the STEM Academy Capstone project for R2D2 Dome. I'm Vinay Belagodu,
I'm Jeff Shea.
and Alexander Hugler will be joining us later. So to talk about why we chose R2D2's Dome, well, we were approached by Mr. Goods and Mr. Polton to come up with a robotics project for prom. Theme this year was the 80s, so we decided to build a iconic movie prop from a movie from the 80s. We chose our favorite movie from the time period, which is Star Wars, and we all decided that R2D2 was our favorite character, so we wanted to replicate it in real life.
So to actually figure out how to build it, we brainstormed and researched a lot. In our research, we came across a big forum full of fellow R2D2 and similar type robots. Um, so using the resources in these forums, we came up with several designs that we were confident would be functional to emulate the details of R2D2 we wanted, and these would also be quite reliable.
Obviously, to have pull off something of this magnitude, we had to have a plan. So we brainstormed a lot and we made a Google Sheet with all the parts that we needed to design, build, all the subsystems, so that way we could all stay organized, know what's up to date, and know what's going on at any given point in time. I specifically worked on R2D2's functions, so this entailed the individual props coming and lifting out of the head, along with the individual pie panels that lift out of the way so that the props can come out of the head fully and shut behind them to cover them up when they're not out. So, as we can see here, we have one of the lifter bases. Some notable points about this base are it's got two little cutouts here. That's so that when the lifter is all the way raised, the hinges can clear it no problem. The other notable point is that these two large holes right here, those are meant for the um, guide rods that we have. So we put some 3D printed bushings in there, filled it with grease, and they slide along stainless steel rods that are hollow. That's to keep the weight down, as well as to keep a really smooth function action as it lifts up and down. The other point to notice here is the screwed on portion right here. That's for a lead screw nut. In our research, there's many different ways that people lifted these props out of the head. One being a pulley setup. I decided against that as we would need to deal with a variety of pulleys and belts and tensioning, and I just didn't feel that would be reliable over the long duration that R2D2 will be operating for prom. I wanted something a little more reliable, a little more simple, a little more practical. Another solution was we explored maybe doing a winch style with like a little string. Again, the issue with that, very unreliable, high chance of getting the string getting tangled, high chance of it getting caught in things, and we just did not want to take that risk. So we ended up with doing a lead screw and stepper motor setup, so very similar to the Z-axis of a 3D printer. Here we see it built in PLA. Later on, it will be in ABS and a little stronger design um, because this was the original prototype. As we can see here, this is our entire base plate that's fully set up. It's comprised of 6 sections, 5 of which have actual parts that lift up. And this back section right here is for the electronics to be housed. Here we have 3 of the steppers installed onto the inner ring of R2D2's head, which sits on a lazy Susan so that the head can rotate within the body, and all the pieces stay lined up with their openings in the top of the head. On the right-hand side here, we can see the underside of the base plate, and we can see the 3 steppers that we have set up there. Again, here on the left-hand side, we have that same image just from a different angle to sort of give you a sense of height. And then right here on the right hand side, we have this wooden dowel sticking out where the guide rods would be. The reason for this is we thought it was going to be easier, cheaper, and just simpler overall to prototype the spacing with wooden dowels rather than metal tubes, because the metal tubes is very difficult to get the right height adjusted, while this is very simple to prototype with to get that final height that we want before moving on to cutting the stainless steel rods that we have. Here on the left-hand side, you can see we are testing and fitting and prototyping the lower ring. So this is what covers all of the electronics and base plate that you see here. It's very important to get this accurate because this is seen from the outside, and this is what we wanted to hold as screen accurate as possible to the films. So we can see here we're trying to make sure it's nice and stiff, nice and circular, make sure it all fits perfectly. Right here on the right hand side, you can see the fully assembled lifter setup. Here on the top, this is a top plate that we made. The reason for this was to make sure that everything stays stiff and we don't have rods that are wiggling left, right, and just not being reliable and not being stable. Each of these has a continuous servo, or three of them have continuous servos on them, so that they can spin either direction. Two of them don't because they are the lightsaber and the bad motivator. Here on the left-hand side, you can see that continuous servo that we have mounted, as well as the gears connecting the two. We grease these up really well, as is with everything else in the lifter setup. We wanted to grease it really well just to make sure that everything was running smoothly and we weren't prematurely wearing out the parts um, during construction and just for prom itself. We wanted to make sure this was reliable and this did not start internally killing itself. Right here on the right hand side, you can see one of the more complex parts, the dome zapper with its more complex hinge setup. Here you can see the hinges. We have four. The fifth one here is not installed because that is a pie panel that goes right on top of the periscope, which lifts itself out and does not need to be cleared out of the way for the prop to clear out. Here you can see four of them just there. We're using a normal 180-degree servo to rotate that and a set of linkages to rotate it out of the way. Here we have a video sort of demonstrating each of the little pieces, and I'm just going to talk you through a little bit as we go through.
Good.
So here we have the um, lightsaber lifting up. This is removable, so if when the dome is on, you can walk up to it and pull it out, wield it, and then put it back in, and it will still function fine. These lifters are currently running off of Alex's electronics for the stepper motors. Here we have the Lifeform scanner, and you can see it's lifting up and rotates a little, but once we get up to the top here, it will rotate in not only one direction, but it can also rotate in the other direction as well. And then it can also lower back down like so. Here we have the dome zapper. This was the one of the more complicated parts. It rotates, but also has the dome zapper arm pop out and sort of zap. You'll be able to see that right here. Yep. That can also rotate in both directions, just like the Lifeform scanner. And that also lowers. Here we have the periscope. This is the one that has the pie panel mounted on top. The reason you can see all this and we don't have the dome on top of this is so that you can really see the mechanism and the internal workings of the head, because when the dome is on top, all of this is fully covered and you can't see any of it. Once again, the periscope also lifts up. It rotates in either direction, utilizing the continuous servo that's mounted. That lowers down as well. Last but not least, we have the bad motivator. Again, this one does not spin. However, it does lift up and come back down. So yeah, that is the functions of R2-D2. I'll now pass it on to Jack to talk more about the design of R2-D2. Okay, continue recording.
Hi, I'm Jack Shea, and I worked on R2D2's design. So that encompasses pretty much any structure or cosmetic part that does not move with electronics. So first off, we constructed the entire dome and lifter assembly using 3D printers. So actually the top left and the middle picture are parts of the lifter base that I just talked about. The picture on the right is parts of the actual structure of the dome. You can see the curvature of the outside, as well as the mounting walls in the end of each panel, which allow the panels to all be bolted together to construct the dome. And the bottom left photo is actually the frame to hold all the pie panels, which the various props come out of and the hinges are mounted to. So the photo on the left is a picture of all the 3D printers at school running to make parts for R2D2, and the photo on the right are some of the completed parts we have. So the one on the top left is the picture you saw, is the part you saw before of the lifter base. Bottom left is one of the lifters actually, that's the bad motivated lifter. The top right is the bad motivator, so that gets lifted by that lifter. And the bottom right is one of the pie panels that flips open to allow the props to emerge from the head. So this is just a quick video talking about 3D printing and our productivity.
Daily productivity. That's done. Say hi, Alex.
Hi.
Hi.
What are we doing?
That's going, that's going, that's going, that's going, that's going, that's going, that's going.
It's not going.
Are you taking a video or are you sending this?
Daily productivity. Daily productivity.
So the photo on the left is right after we had just finished constructing the dome. So each ring, so there's the bottom ring, the middle ring, and the top. Each one is bolted together with the panels next to it. And the three different levels of rings are all epoxy together. So epoxy is just this two-part glue we use that makes a very strong bond with the plastic parts. The photo in the middle is while we were preparing the dome for paint. So we had primer we sprayed on the dome, as well as we used some putty to fill in larger cracks in the dome to really smooth out the surface. And the picture on the right is just when Vinay decided he wanted to be R2D2. So this is part of the painting for R2D2. We were putting the first coat of silver paint on the dome. We actually used two different shades of silver to get the correct color, the sort of gunmetal type finish. So the first coat we did it was a very light metallic silver. It was a very aluminum-esque. And after that, we had this almost black silver, which would give a very light coat to have the correct shade of gray. So that picture on the left is the very light silver. We thought it was too light of a shade for R2D2 to really emulate the movies. So you can see the two pictures on the right have the darker color on it, which we think is much closer to the movie, and we think it looks better. You can see the blue panels; those are all 3D printed, painted with some blue paint. And the picture on the left is actually just a test fit. Nothing is glued in. I wanted to make sure that everything fit before I committed to gluing them in. And the picture on the right is after everything had been glued. You can actually see there's two rings on the bottom that have been painted as well, as opposed to the middle picture. And this is just when we were getting, right before we were getting ready for final installation of the dome onto the lifter assembly. So as part of the Capstone project, we were required to attend a STEAM expo at an elementary school.
So to meet this requirement, we decided to go to Makefield, as seen on the left, and to Afton, as seen on the right, both their STEAM expos. The reason for this was because Alex and I are both graduates of Afton Elementary, while Jack is a graduate of Makefield, so he really wanted to go out and present at these two middle or elementary schools specifically. The reason for this was because we believe that's really important to encourage the next generation of engineers in Pennsbury to show them what is capable at the high school, what they're capable of learning and doing once they get up to the high school and eventually, because we feel that engineering needs to be promoted and advocated for that to really bring up the next generation of engineers that will change the world. And this is our little way of helping out with doing such activities.
Yep. So at the expos, we brought our prom project from last year, which was a 15-inch wide robotic eyeball that obviously blinks and moves left and right like any eyeball. But there's also a small camera that isn't visible right now that's inside the iris, which allows the eye to actually lock onto somebody's face and track them as they walk around the room, following them. In addition to the large eyeball, we brought the first prototype, which is that little blue version of the eyeball next to the large one. The first prototype is obviously to test all of our ideas, make sure they work correctly before committing to a larger, more expensive version. Then there's also a computer monitor having a quick slideshow of CAD models, ideas, and pictures while during construction. There's also a computer that's not visible, which had the CAD models of the eyeball, which the elementary students could interact with, making the eyeball blink, moving left and right, which hopefully really inspired them to consider engineering.
Well, overall, thank you so much for watching our presentation about R2D2. If you would like to see the lifters in a little more detail, they're linked on our YouTube channel, as is the hinges. They're going to be also on our YouTube channel as well. Otherwise, thank you so much for your time, and we hope you enjoyed learning how to build an R2D2 dome.
Thank you.
Thank you.